A ball rolls off a table horizontally with a speed of 11.8 meters per second. The table is 1.1 meters above the ground. How long is the ball in the air? And find the speed in which the ball hits the ground. So we have two things we're finding here: the time the ball is in the air and the speed where the ball hits the ground. So what we're going to do first is we're going to set up two things, one for horizontal and one for vertical, and then you're going to fill in what you know. So one thing we definitely know is the initial velocity for horizontal is 11.8 meters per second. So you just fill that in. And we also know that the table is 1.1 meters above the ground. So for vertical, the displacement is 1.1 meters. Next, we just fill in everything else we already know. For horizontal, you're not accelerating at all, so the acceleration is 0 meters per second squared. And because you're not accelerating, the initial velocity and the final velocity are the same. So the final velocity will also be 11.8 meters per second. For vertical, we know it involves free fall, so the acceleration is negative 9.8 meters per second squared. The initial velocity is 0 meters per second. Now that we have all of our information that we already know, we just have to find the time for vertical using one of these two equations. The equation I'm going to use is displacement. So what you're going to do is you're going to plug in these numbers for the vertical side into this equation. And since initial velocity is 0, this right here, initial velocity times time, that equals 0. So that's knocked right out of the equation. So you're left with x equals 1/2 times the acceleration times time squared. So now we have to get time all by itself. So what you're going to do is you're going to get rid of this 1/2 first by multiplying everything by the reciprocal of 2 over 1. So then you get 2x is equal to acceleration times time squared. So then you divide everything by acceleration. So you get 2x over a equals time squared. And you still have a t squared. So what you're going to do is you're going to take the square root of both sides to get rid of that t squared. So you're left with the equation t equals square root of 2x over a, which is 2 times displacement divided by acceleration. And if you look back here, we have both displacement and acceleration, so all we need to do is plug it back into this equation. And we're going to do that by using unit analysis. So put a 2 here, and times acceleration, so 1 times displacement, not acceleration. Then it's divided by, I'm going to do a positive 9.8 meters per second squared because time is not negative, it's positive. So then you just plug that into your calculator. And once you plug that in, you should get 0.22448, and it just continues on. And these meters cancel out, so you're left with seconds squared. But since you're left with the squared, you once again have to take the square root. So just put that into your calculator, and you should get 0.4738, and it continues by, just rounded mine up to 0.474 seconds. So that is your time for the vertical. Now what we have to do next is find the speed in which the ball hits the ground. Now that is something a little bit different. In algebra or geometry, you learn a squared plus b squared equals c squared. That's the same thing for this. That is how you find the speed in which the ball hits the ground, because you have two velocities, and then you just need to find a third one, which is c squared. However, first we need to find the final velocity of vertical. So we can do that by using this equation right here, because it has a final velocity in it, whereas this one does not. So we're going to use this equation, and since we need to find final velocity, we have to get that all by itself. So what we're going to do first is we're going to times time on both sides, so these cancel out. So you're left with a times t equals vf minus vi. So then next, you're going to add initial velocity. So you're left with a times t plus vi equals vf. So now you have the final velocity all by itself, and you can plug it in with these numbers. So we have the acceleration, and that's negative 9.8 meters per second squared, and we're going to use unit analysis again. And then that times the time, which we just found, which is 0.474 seconds. And then you add the initial velocity, but since it's 0, we don't really need to put it in there. So then you just plug this into your calculator. And since we're using unit analysis, and there's a second squared here and a second there, you just cancel one of these seconds out, and cancel that second out, so you're left with meters per second. And in your calculator, you should have gotten negative 4.6452, but I just rounded it to negative 4.65 meters per second. So that is your final velocity. So now that we have our two velocities, 11.8 and negative 4.65, we can now plug those into a squared plus b squared equals c squared, and then we can find the speed in which the ball hits the ground. So this is just like what you learned in previous math classes. 11.8 is going to be A, and negative 4.65 is going to be B. You can do this one of two ways. You can either plug into the calculator 11.8 squared plus 4.65 squared, or you can actually square them out and then add them like this. And then if you add them out like this, you're going to get 160.86, and you just take the square root of that to get 12.68 meters per second. So that is the speed in which the ball hits the ground. But if you do it in this step, you just add them and take the square root of the answer to get 12.68 meters per second. And that's it.